Hello everyone. So welcome to my YouTube channel Zenith GATE Mechanical. So let's move to the questions which came into the GATE 2026 mechanical paper from the engineering mechanics subject. Okay. Now this is the first question, which of 2 marks of 50 kg mass is on inclined plane. The block is connected to the another hanging mass M. Okay, by an inextensible massless string through the two massless pulley. Okay, so the mass of the pulley is not given. That means it is a massless, as shown in the figure below. The coefficient of static friction between the block and inclined plane. That means here the coefficient of static friction is given as 0.3. 0.3. Fine. So the coefficient of friction is given as 0.3. Now, neglecting the pulley friction, that means there is no friction which is basically in the pulley. So that means the tension on the both the side of the string will be same. They have given the friction value, coefficient of friction value. So the tension on both the string will be different, because you know that T1 by T2 is equal to e to the power of mu theta. But mu value, it is not given in the pulley. That means both the side the tension will be same. This is the first key point. The minimum value of mass M which is required to start the upward motion of the block. Okay. So what you have to calculate, what will be the minimum value of this mass M, so that this block will try to move in the upward direction. Okay, very beautiful question. Now see, and this is a NET problem, round off to the 1 decimal places. Now, first of all, what we will do, so if this block is trying to move in the upward direction, definitely this will try to move in the downward direction. Okay, that means there will be one tension. And another force which is acting on this block is its weight. If this tension will be here, so same tension you will get here, and the tension will be here. Now at this point, if I want to mention what is the force, the total will be 2T. This is T and this is T. So at this particular point, 2T. So this 2T force is basically acting over this particular block. Okay, this is the one of the force. Now, what are the other forces is basically acting on this 50 kg mass? Okay, so first of all, you have to draw the free body diagram. The free body diagram of this block, which is resting on the inclined plane, and the inclined plane has an inclination of 30 degrees, which is already given in the question. So what are the forces which will act over this block? First of all, its weight, which is acting in downward, which is nothing but 50 g. If this is 30 degrees, so this is 90, and this will be 90 minus theta, so this is theta only. So can I say this value will be 30 degree only? So that means this is 50 g cos of 30 degree. Now, if you resolve this along this inclined plane, you will get the 50 g sine. You will get the 50 g sine 30 degree. Okay. Now, this is the one force which is acting over the block mass 50 kg. That is nothing but the weight of this block. The another force, as you know that this block is making a contact with this inclined surface, and there will be definitely one normal reaction because it is making a contact. So the normal reaction will acting perpendicular to the surface of contact. That means this is the normal reaction. Now, the another force, what will be the another force? As you know that here will be 2T will be the tension. Fine. Now, it is mentioned the minimum value of mass M, which is required the upward motion of block. That means it is trying to move in the upward direction, and there will be a friction present, the coefficient of friction, and definitely the friction force will also act, which will act in the downward direction. This is nothing but the friction force 0.3, which is nothing but friction force is nothing but, I will write here friction, and friction is nothing but mu into normal reaction. Fine. Which is nothing but 0.3 times of normal reaction. Okay, so you can see here you have drawn the free body diagram of this block. Now what you will do, you just write down the equilibrium equation. That's it. Okay, so summation of force in the y direction. What I will do for making a simplicity, I will take this as x-axis and this is y-axis. Okay, so if you write the expression for summation of force in the y direction is equal to 0. What are the forces acting in y direction? One is normal reaction and another is equal to 50 g cos 30. So the normal reaction is equal to 50 g cos of 30. Okay, cos 30 is root 3 by 2 and this will become 25 g into root 3. So which is nothing but 43.3 g. Fine. So the normal reaction you have calculated. Then this normal reaction you will utilize in the friction formula. Now, if I will write the expression for summation of force in x direction 0, so can I say this 2t force will be balanced by this force and this force? So 2t force is the upward, which is positive, and negative I am taking as a minus 50g cos sine 30 and friction. So what I will do, I will take in the right hand side. So 50g sine 30 plus friction value, fine. So this is nothing but sine 30 is 1 by 2. So can I say this is 25 into g, and the friction coefficient is 0.3 and the n value which is given as 43.3 into g. So from here, you know that this, if you see this particular block, this tension force is equal to mg. So if you will put the, let me take the next slide. So the tension force, so 2t value you got as 50g sine 30, which is 25g plus 0.3 into 43.3 z. And you know that there is a block of mass m. So here is the tension is acting, here is the mg. So you can just put the value of tension value, which is mg. So this is 25g plus 0.3, 43.3 into g. So gg will cancel out. That's why I have not kept the value of g initially. So now you will get the mass value. Okay. So the mass value, once you will solve, you will get as 19 kg. 19 kg. Okay. 19 kg. Okay, so this is an NAD problem. So definitely you will get the range, but the correct answer for this question is 19 kg. Okay. Now let's move to the second question, which is from the instantaneous center concept. Now see, a rigid cylinder bar AB, which is sliding against the two mutually perpendicular frictionless wall. There is no friction which is given. As shown in the figure, the velocity of A in the downward direction at a given instant is 6 meters per second. At that instant, the magnitude of absolute velocity at the midpoint g you have to calculate. So if you see this particular bar, it is doing the general plane motion. General plane motion means translation as well as rotation. Because after some instant, if you will observe, this bar will be like this. Okay, so this point will come here and this point will reach at this point. So it is doing translation as well as rotation. Fine. Now, for solving this problem, what we will do, first of all, we will locate the instantaneous center. So instantaneous center is that point at any particular instant where you can assume this body is doing completely rotation. Okay. Usually this particular body is doing translation and the rotation, but at certain instant, with the help of instantaneous center point, you can assume this body is in completely in rotation. Okay. So if I will mention here, point I, I'm assuming the point I is basically instantaneous center. How you will locate? Just draw the perpendicular to the velocity direction. So this point A is coming in downward. So we can say that this B will go in this direction. So if you will draw a perpendicular to this velocity vector, so you will get some intersection point that is nothing but the instantaneous center. So at this particular point, you can assume this body, which is completely in the rotation only. Fine. So it is rotating about this instantaneous center. So point I is the instantaneous center of bar AB. Okay. So the bar AB is in pure rotation. Bar AB is in pure rotation about I. About I. Okay. Now, So if I want to calculate the value of the velocity at the G point, absolute velocity at the G point, so this distance, if it is, let us suppose the length L, so this distance will be L by 2. So L, I am assuming the length of the complete cylinder bar. Now this will become L by 2. Fine. So from the instantaneous center concept, you can write, because this is in completely rotation. So each and every point we can assume is in the completely rotation part. So Vg divided by Gi is equal to Va divided by Ai. Okay. Va divided by Ai. So from here you will get the value of Vg. From here you will get the value of Vg, because Va value, it is already given. Va, velocity at A point, is 6 meter per second. Gi divided by Ai. So how you will get this value of Gi and Ai? Now you can see here, Gi, the length of this cylinder bar is L. So this is L by 2. So 6 into L by 2. Now what is Ai value? What is the value of Ai? This is L. So can I say this is 45? Then it will be L cos 45. This is nothing but L cos of 45 degree. So this is L cos of 45 degree. Now from here you will get the value of 3 root 2, which is nothing but 4.24 meter per second. 4.24 meter per second. If you see, this is nothing but V divided by R, which is nothing but omega. This is also V divided by R only, because AI is the distance. Okay. So if you observe this particular relation, V divided by R, V divided R will be constant only, because it is completely in the rotation. Completely in the rotation. So the correct answer for this question is 4.24. So let me check. Yeah, they have mentioned round off to 2 decimal places. So the answer will be 4.24. 4.24. Okay.